class 6. Welcome to chemistry class once again. In my previous class I have started chapter number 3 matter, and I have taught you there states of matter. So there are 3 states of matter: solid, liquid and gas. There are even 2 other states of matter that exist in nature. And what are they? Plasma and BEC, Bose-Einstein condensate. Plasma exists at very high temperature. BEC exists at very low temperature. But these two we are not going to learn in detail. Okay, in detail we learn about solid, liquid and gas. So in my previous class I have taught you about solid. Okay, that what is solid? The state of matter that has definite shape, definite volume and that cannot flow from one place to another on its own is called solid. Okay, and even I have taught you 2 activities. First activity was to prove that solid has a fixed shape. Okay, and the second activity was to prove that solid has fixed volume. Okay, so today I am going to teach you about liquid and gas, other 2 states which were left. Okay, that is liquid and gas. Okay, so let's start with the what? With the other state of matter. I have already said you that states of matters are states of matter. So there are 3 states. What are they? Solid, liquid, gas. Okay. So about solid I have already taught you in my previous class. So let's start with the what? Second state of matter, that is liquid. Now what is liquid? What is liquid? Okay. The state of matter which has a definite volume but no definite shape, okay, and which can flow from one place to another in some direction is called liquid. Okay, so liquid do not have definite shape. Okay, liquid do not have definite shape, it has definite volume. So that is why, as liquid do not have definite shape, that is why the liquid take the shapes of the containers in which it is poured. Okay, and whatever you will pour the liquid in the shape of whatever the container is, it will take the shape of that container. Okay, so liquid, they do not have definite what? Shape. Okay, they can flow from one place to another. Liquid can flow from one place to another given. Okay, and what are the examples of liquid? Water, juice, petrol, kerosene, many more examples are there. Okay, so this was the what you say about liquid. Now let's see the activity. There are 2 activities about this liquid based on this liquid. So now let's see what is the motive of this activity. Okay, what they want to prove. So what is activity 1? What is the aim? Now let's see. Aim: to show that a solid does not flow from one place to another but a liquid does. Materials required: glass tumbler, water, rice grains. Let's start the procedure. What is the procedure of this activity? First, what you will do, you will take a glass tumbler and you will take some rice grain in that glass tumbler. Okay, and after taking the rice grains in that glass tumbler, what you will do? You will spill it on the floor. You will spill it on the floor. Okay, now next what you will do? You will take again the glass tumbler, okay, and you will fill that with water. Some amount of water you will fill in that glass tumbler. And again what you will do? Again you spill that glass tumbler, okay, on the floor. So water will flow out. Now what is the observation is that? First you have taken the tumbler, okay, you have taken the glass tumbler which is what? Which contains the rice grains. So as you spill it on the floor, you will see, okay, that it will roll. Okay, it will roll and it will spin. Okay, but it will not flow. It will not flow, no. What rice grains are solid. It will not flow. It will roll. Okay, few distance it will roll, but it will not flow. Whereas when you have spilled a glass tumbler containing water, so what you will see that it will flow. And it will occupy more space than rice grain. It will occupy more space than rice grain. The water will flow and it will occupy more space, and water will flow in all the direction. Okay. So this activity proves that we come to the conclusion that, okay, what we come to the conclusion that solid do not flow. Yes, what solid will only roll or it will spin, but it will not flow as a liquid. Okay, liquid flows. Okay, liquid flows. Water, yes, water will flow. You will see that water will flow. And you have seen this many times also. Sometime your glass of water, when it falls down, you see that water spill everywhere. It start to flow, no? It start to flow. So this activity proves that solid do not flow, liquid flows. Okay. So now what is the next activity? Let's see, and what is the aim of that activity? Activity. Aim to show that a liquid, number 1, does not have a definite shape. Number 2, has a definite volume. Number 3, can flow by itself. Number 4, has only one free surface. Materials required: colored water and ink or watercolor to color the water. A few containers of different shapes, a beaker, a plate and a measuring cylinder. Okay, this is the second now what is the procedure is that you will take a measuring cylinder, and in that measuring cylinder you will take 20 ml of water. How much you will take? 20 ml. You will measure in that. Okay, after taking that, what were the materials? Different types of shapes of container also we have taken. So you can take any shapes of container. Okay, you take one glass. Okay, any other shape. So many other types of shape of the glass comes now. So you can take any shape. Okay, so you can take this type of shape one also. So you can take any shape. Okay, so you will see that when you will pour that 20 ml you have measured in a measuring cylinder, and you will pour in the different shapes of the container. Okay, this was the procedure number 1. Okay, now number 2, what you have to do? You have to take the plate. In that plate you have to take water. What you will take a plate. Okay, you will take a plate and you will fill this plate with water. Okay. Now next what you will do is that you will lift the plate from one side. Okay, you will lift the plate from one side. Like think this is the plate. Okay, so I fill this plate with water. Okay, and the next thing what I will do, I will lift from one side. So when I will lift, the plate will get slanted and the water will start to flow. Water will start to flow. Water will start to. Okay. Now what is the observation? Now what is the observation? Number 1, what we have done is that we have taken 20 ml of water and we have poured the 20 ml of water in different shapes of container. So you will observe that 20 ml water will take the shapes of the different containers. It will take the shapes of the different container, no? That 20 ml will take the shapes of the different container. This shows that what liquid do not have definite shape. Number 1 was that we have taken 20 ml of water and we have poured in all the different shapes of the container, and we conclude that what liquid do not have definite shape. It takes the shape of the container, no? First you have measured that 20 ml of water, then you have poured in different containers. So it will take the shape of the different containers in which it will be poured. So it proves that liquid do not have definite shape. So when you will take 20 ml of water, okay, and you will pour in the different container, so it is taking the different shapes, okay, but the volume is not changing. Volume do not change. The volume is fixed. So liquid has a fixed volume. Okay, liquid has the fixed volume. Okay, now in this plate 1, okay, we have taken the water in the plate and then we have lift from the one side. Okay, so all the water it starts to flow. This shows that liquid flows. Okay, liquid flows in some direction. Okay, it is free to flow. Okay, now the liquid. Okay, we have taken in each container, it takes the shapes of the container, but the label will not change. If it in this container, if it is up to this much, so it will remain up to this much only. Okay, it will remain up to this much. But some there exceptions are there. Okay, like petrol. Okay, a perfume, nail paint removers and all. If we leave this liquid open, okay, this changes its states into vapor state. At a low temperature they changes its state, okay, from liquid to vapor state. That is why, okay, these types of liquids are called the volatile liquids, okay, and we keep these types of liquid closed, okay, in a airtight container so that it will not escape. But here if I have left this water open, the label will not change, okay, the label will not change, it will not get, what is it, converted into the vapor state, okay. But if I leave this, what is it, petrol, nail paint removers and all open, okay, so it will get escape, okay, it will get converted into the vapor state at low temperature, okay. And last, what is given, that it has only one surface, okay, so liquid has only one surface, no. So liquid have only one surface means that you can see the only top surface, no, rest all the surface is surrounded by the walls of the container. Solid has many free surfaces, but liquid have only one free surface, that is the top layer, okay. So I have taught you all about the liquids, okay. So let me say it again, that liquid, they do not have definite shape, they have definite volume, they can flow, okay, they can flow, they have only one free surface, okay. It take the shapes of the container in which it is poured, okay. We cannot cut the liquid. Can we cut the liquid like we can cut the solid? No, we cannot cut the liquid. And examples of liquids are what? Juice, water, and all are the examples of what? Of liquid, okay. So now let's go for the last one, the third state of matter, that is gas, okay. Now what is gas? Okay, what is gas? The state of matter that has no definite shape, no definite volume, and which can flow in all possible direction is called gas, okay. And gas has no free surfaces, okay. Like in solid, it has free surfaces, okay, many free surfaces are there. In liquid, it has only one free surface, okay. But in gas, there is no free surface, okay. Gas, it occupies the available space, no. The gas can flow in all the possible direction, and wherever the space will be available, it will occupy that space, okay. Gas exerts the pressure in all the direction. Pressure means it is the force per unit area exerted by a object against a surface, okay. And what are the examples of gases? Oxygen, hydrogen, carbon dioxide, nitrogen. So many examples are there, no. So this was about gas, okay. Now there is one activity about this gas, okay. So now let's see what is this activity, and let's do the activity, okay. Aim to show that air exerts pressure. Materials required: a peeled hard-boiled egg, a glass bottle having a mouth in which the egg does not slip in easily, and which has a side pipe fitted with a rubber tube. Now, what is the aim of this activity? Okay, I have already said you that aim is to what? Show that air exerts the pressure. Okay, so here I have made the drawing already. So now I am going to explain you one by one. Okay, now what is the procedure? Okay, the procedure is that you have to apply the oil at the mouth of this glass bottle. Okay, and you have to place the egg, and you will see that egg will not go into this bottle. Okay, now next step. Okay, what we have to do is that we have to put this egg in this glass bottle, but it has got stuck here. It is not going into this bottle. So what we have to do? Okay, now next you see, number one was that. Now number two is, now next what you have to do is that, okay, you can see the side pipe fitted with the rubber tube. Okay, it is fitted with the rubber tube. What you will do? You will suck all the air out. What do? You will suck all the air out. Whatever the air is present in this glass bottle, okay, you will suck all the air out through this side pipe fitted with the rubber tube. Okay, what you will do? You will suck all the air out. And as you will suck all the air out, okay, what you will see that the egg will squeeze, okay, and it will slowly slide into the bottle. Okay, now why it has slide into the bottle, how it has slide into the bottle, okay, I will tell about this in my observation and conclusion. Okay, so first you just see what I am saying. Okay, now fourth. What is that? You will invert the glass bottle. First, we have tried to put this egg into the bottle and it has what? It has slide slowly and it went inside the bottle. Now I want to take this egg out of this glass bottle. Now I want to take this egg from this glass bottle, out from this glass bottle. Now how I will do? As I will invert this bottle. Okay, as I will invert this bottle, okay, this egg will come up to neck. Okay, it will come up to neck, but it will not what? It will not get out of this bottle. Okay, so how to take this egg out? Now next what you will do is that you will blow the air through this side pipe, okay, fitted with the rubber tube. Okay, you will blow the air. What you will do? You will blow the air. In first case, you have sucked all the air. You have taken all the air out. In this case, you have to blow the air. As you will blow the air inside this bottle, you will see that egg will squeeze. Okay, egg will squeeze and it will slowly slide out of this glass bottle. Okay, now why it is so? Now let me see. Observation. In first case, you have observed that when you have sucked air out, the egg slowly slide into the bottle. In this case, when you have blown the air in the glass bottle, what you have seen that egg has slowly slide out. Okay, now what is the conclusion that when I have sucked the air out from this bottle, okay, so the pressure inside the glass bottle has become less than the pressure outside the bottle. Okay, when I have sucked all the air from the bottle, so the pressure, okay, the air exerts pressure, so the pressure exerted by the air, okay, inside the bottle becomes less. So the pressure exerted by the air inside the bottle becomes less than the air exerted. What? Air exerts pressure outside also. Then the pressure exerted by the air outside. So the pressure inside the bottle is less and the pressure outside exerted by the air is more. So the air exerts the pressure on this egg. Okay, the air exerts the pressure on this egg and this egg squeezes and it slowly slides inside. Okay, because of the air pressure, because of the what? Air exerts pressure. Okay, because of the air exerts pressure. This proves that air exerts pressure. As air has exerted pressure, that is why the egg, what, it has slide into the glass bottle. If air would have not exerted pressure, so is that if this egg would have gone inside this bottle? No. So this proves that air exerts pressure. Okay. Now in second case, how this egg has come out? Okay. So in the second case, what we have done, we have blown the air. What we have done? We have blown the air. So as we blow the air inside this glass bottle, so the pressure inside the bottle exerted by the air becomes more than the pressure exerted by the air outside. Okay, so the air, what I said, again I repeat, okay, that the air exerts more pressure inside the bottle as we have blown the air. What we have done? As we have blown the air. So air has exerted more pressure inside the bottle than the outside. So the air exerts pressure on this egg, okay, on this egg. So the egg squeezes, okay, and it slides out slowly. Okay, okay. So as we blow the air, okay, so the air inside the bottle increases than the air outside. Okay, internal air pressure is more than the external air pressure. So the eggs come out. Okay, so in this case we have sucked the air out. Okay, so inside the bottle, okay, the internal air pressure was what? Less than the external pressure, means the outside pressure. was more. In this case, the outside external pressure, the external air exerts more pressure than what internal air exerts. So, okay, what I said is that, again I repeat, okay, again I repeat that inside this bottle, pressure exerted by the air is less as we have sucked all the air out, and the pressure outside is more. Air exerts more pressure. So this external pressure pushes this egg, okay, and this egg slowly what it squeezes and it slides inside, okay. And in this case we have blown the air. So what you have seen is that, what you will see is that the internal pressure increases, air pressure increases than the external one. So the pressure inside this bottle, okay, exerts more pressure, air exerts more pressure inside this bottle, so it pushes the egg, okay. That air exerts more pressure and it pushes the egg, so egg squeezes and it slides out of the glass bottle, okay. So this proves that air exerts pressure. If air would have not exert pressure, the egg would have not slide inside the bottle, or it would have not come out of this bottle, okay. So this proves that air exerts pressure. So today I have covered two topics, okay. Today I have covered two topics with 3 activities, okay. So I hope you have understood. Learn at home whatever I have taught you, and if you have any doubt you can ask me, okay. And you can ask me, okay, on my WhatsApp number, okay, you have, so you can ask there, okay. If you have any doubt you can ask there, okay, regarding my subject. If you have any doubt you can ask me, I would clear it, okay. So for today up to this much, you read this all at home, okay. Thank you.